Okay, we are live. What's up, guys? Here I am going to explore today compression. So we are looking at a mechanism to take a file that has been uploaded to S3 and recompress it. It would be really nice if S3 supported that. Well, while you're uploading something, you just tell it, hey, can you compress this for me? On your server, and you just give it the compression algorithm. Unfortunately, they don't support that. And I wanted to explore what it would look like, go through the code. I already have code written basically. We'll test it, make sure that it actually works locally. And then we're going to move on to actually hosting this on AWS. That's what I'm targeting today. Hopefully you guys find this enjoyable. Let's get started. So I have this code written. It was written on a whim, so we'll need to tweak it. So basically, when I initialize a module, these are some other modules. So let's look. I always forget this command. So go module initialize. Let's see. Oh, also, the other thing I did want to do is look at code. Let's look at the downloader component. Just another piece of code here. Oh, one. Oh. So we're gonna go look at code.mod. Okay, so this is our URL. We're gonna do a go mod init of not downloader. In this case, it is the compressor module. Cool. And now we're gonna do go mod tidy to clean this up. Awesome. Amazing. So this is good. Now let's take a look at our code. So first off, I'm getting an error, undeclared load request. But it's declared right here. I'm not really sure why it's complaining. Probably is a typo. Yep. Okay. Let's look at the load request function. So as I said, this will be hosted on ECS, so it's actually accepting its inputs via through env variables, because when you call the run task API, you can't really give it parameters. It would be nice if you could, but that's okay. So I might actually wrap all this so it's a little bit easier to test. So let me wrap this all. Actually, you know what? I'm gonna test it all as a unified function. Break it down basically and be able to test bit by bit and then run them as if it's like the part of the main. Okay. Okay, so we're basically loading the request from the env variable. If we can't find a payload, we're gonna panic. I'm really panicking here because this is like such a short-lived task. So there's not a ton of error handling in this case. Truly, if there isn't a request, there's nothing we can do but fail. Let's see, we're parsing it. Obviously, this can also result in an error. So we're gonna return this error here, and we're gonna panic if there's an error. Moving on. So let's look at the download here. I wanted to do a log, and I thought for a second that I'm writing JavaScript code or something. Let's see. Log.I completely forgot this. Oh, just print, I guess. Print F. Then we need a new line character. I like to have some debug logs. Very cool. Size here is an undeclared variable. Yep, need to do a walrus operator. I'm gonna panic if there is an error. I think in my panic function, I'd like to log the error before panicking. Log. Fatal. Which I think is what we want. Cool. I actually need to print F here. Same thing. There's a typo. This returns the compressed path, I guess. Suffixes it with the .gz. Which is good. And then it uploads, takes the compressed path, and uploads it using maximum currency of 50 and 64 megabytes per partition. Yep, same thing. Yep, I think this should be good. Yep, we need to flip those for the upload here. I think I have just key percentage file path. We need to dereference this. Oh. Interesting. This is going to return the size. We don't really need to return the sign. But it would be nice to know that the upload did. compression failed due to, and then we put in the error. Well, we just don't need this. In this case, I think it's going to be like okay. And this is exactly how I will write it. Fail if. Yep, this returns an error. Interesting. So I'm not really sure what the difference is. I'm just gonna go with wait since I've used it before. We're also using here pigs, which is an interesting choice. It's a parallel compression CLI utility. Seems like it's pretty old. Let's just take a look at what pigs is. Let's do pigs Linux. There we go. Pigsy. Yeah, I've been calling I've been calling it pig. Pigs. Pigsy, okay. So yeah, so Pigsy. Yeah, they're gonna have a man page for it. To be honest, there is a different utility that's actually written in Go, and it claims to be faster. However, I don't know if I trust it enough, and this is a battle-tested tool. So I'd rather use this. Okay, I think we are good. I want to write a unit test just for the sake of completeness, if you may. So I might do that. Also worth noting that initially I wrote this code in like another module, but I realized that it's kind of silly due to the nature of the code. So I might honestly just copy the test and create or just move the compressor from Swift Go compressor test Go into here compressor underscore test. Cool. So obviously this is not gonna work, so I'm gonna create a main, and then I'm gonna do go get this module. Nice. So we're gonna do that, which is nice. This we actually need from our other module, and if I remember correctly, go local module. Pretty sure I had a pretty good tutorial for this. Cool. So you create your other module. yeah, we've done this before, so we're gonna do go mod edit, like it says, and we're gonna do dash replace. Let's see, we got get swifty dot app. Let's check the name of the module. So cat swift go.mod. Yep, so it's just slash swift. Or we're gonna do this is equal to swift minus go. And we're gonna import here this thing. .netlify.app, let's do that. Yeah, we should fix this, but I'll fix this later. Get swifty.netlify.app. Perfect. I'm gonna add it. Let me turn on. It's interesting. So I think what we need to do. Yeah, we need to turn off some Go features. So what I would say is let's just do it from here. Vim compressor underscore test. And then let's do, yep. Let's save this. Yeah, well, it's not gonna find it. Oh yeah, I think you just need to do go mod tidy. Yeah, let's just change this to go. Let's see. Yeah, I don't really see the. Oh, looks like it got fixed. No, I mean, just looks like it works now. Interesting. Even though we got some errors, looks like it works. I'd love to investigate why this was, but I don't think it's as important right now. as actually running the test. So that's exactly what we're gonna do. We're gonna look at the writing the test for this thing. So we're just gonna call this test compressor. Oh. Well, new compressor is not gonna be there. That's unfortunate. I thought this is fixed. Okay, let's see. Nope, I don't think this is fixed. Okay, so okay, let's see. Oh, I need to do Swift dot, and this is not gonna work, but we don't really need this. I think this is the problem that we ran into before. Yes. Yeah, it would be good to wrap this in something. I agree with you that yeah, let's just do a func new instead of func new of this thing. That is able to take an optional parameter. Let's just give it type. Let's just give it a compressor. Pouch struct. Just give it a session. And then session, not session, so yeah, let's just call this compressor props, and let's just do props compressor. Which, yeah, it should return something. Not really sure what that something is. So let's see. So we're gonna do a session. Let's make this a pointer. Yeah, perfect. So we're gonna do if props dot session not equal to nil. Props dot session. Else I think that for whatever reason they don't like this. It is kind of weird how they don't really have a... And I would say, yeah... Yeah, this is a little harder to test because of this, so we're gonna pass in the session. Yeah, no, this might be a little bit too much overkill for a test. I've already tested this, so I think I'm okay. I'm actually gonna delete it. Looks like we have one problem here. Field is unused somewhere, so I'm gonna remove it. Looks like we're back. Okay, we're gonna be running the test just end to end, which I think is okay for this case. I didn't used to be really into writing unit tests. I found it as a waste of time for personal projects. But lately, I have gotten really into the idea of writing tests. I just need to get better at it and be much quicker, so it's more efficient for me. So what we're gonna do here is we're gonna create a Docker file, and we are gonna copy a Docker file from the downloader as well. So let's see. I like to use the downloader since it is also a task. So let's take a look here. Might be quicker to just open the Docker file. Cool. Let's copy this into our local Docker file here. Yeah, so we created a directory called task. We're gonna copy the compressor in this case. And the command is just the compressor. I believe you need this anyways, but I'm gonna do a pigz. So yeah, now we just need to test it. It should have everything for the compression, parallel compression here. Yeah, let's just test it. I guess this might fail. Let's see what we did. Now let's open our infra code. Code cdk root source or stacks root stack. There's a lot of code. Okay, we have our compressed task. the compress task. Let's see. I think go build compressor.go. And then I think if I try to run it, right, it's gonna fail, saying that there's a problem in the env variable. But if I pass a request, let's just say it's empty request. Just gonna do ooh. Huh. Obviously, we're missing a lot of validation, but it seems like compression failed due to open is a directory. Yeah, so this is likely here. Yeah, it's a little bit clearer if you panic with the error. So I might do that. Let's try this. Let's see if this is a little clearer. Yeah, this is at least gives us a stack trace, which I find a little bit better. So I'd like to keep this. Compression failed due to oh. There might be a way to do log dot fatal stack trace. Looks like it's a lot more complex than need be, so we're gonna stick to just doing this. Okay. We can try testing it with real data and seeing if it works, but to be completely honest, I think we should be good. I'm gonna do a go build again, just to be safe. I'm gonna run it one more time. Cool. we're gonna test uploading it. Basically, we created this compressor task here that is in this downloader task. This is all CDK code. I bumped up the memory of it just because I think we want yeah. Okay, so now let's try to deploy this. Let me open another. Let's see, Swift here, actually CDK, and I'm gonna run the npm run deploy. I am gonna authenticate into my AWS console here while we wait. It is C. Cool. Looks like we have our AWS account. Which is amazing. Let's first see what they are saying here. Let me expand this. So they're gonna basically allow the compressor task to some interesting things here. I'm gonna try to deploy this right now. It was totally fine. Looks like it found it. It's publishing the task. Once it's there, I think we can go ahead and test it. So let me just prepare the ECS console here. To run the test. That's the container service. 11 changes to my stack. Maybe one day we're gonna get to a point where I can be sponsored by Pellegrino. Shout out Pellegrino. Okie dokie, so let's take a look at this. We have a couple of different tasks here. We should at least, I should have at least one. So no tasks running. Let me expand this a little bit. I also like to zoom out just to get a better view, but since I'm streaming, I'll give you guys the 100% experience. So let's take a look at our our upload. 87 seconds. I have found that with CDK, once you actually understand it and you know how to write its code, like infra deployment is just so easy. So let's try to run a task. Specify revision manually. Actually, let it just do its thing. Version 1. I'm gonna run on the default VPC. Yep. So we're gonna try to test this. We might want to. I don't know where we can give some parameters. I think this will fail. Let's see. Yeah, I don't think. Yeah, this is just gonna start and it'll fail. It's fine. I kind of want to be able to see the task itself. Let's take a look here. Yep. It's actually super quick. I find that fascinating. So I think it'll automatically stop. Like I don't think I need to stop it or anything.
It's 6 o'clock.
Yep. It automatically stopped. So we can select this, stop selected, click on the term, stop. That is interesting because it's already stopped, so I'm not really sure why it does this. Okay, anyways, I feel like I have a script that makes me run these things, that makes me run this, so I'm gonna check for that. Copy file, run downloader, yep, that's exactly it. Cool, so we're gonna clone this. I'm literally gonna just copy this, copy. I guess I'll do run compressor. And I'm gonna copy some of this. Compressor task 1. Okay, so let's see here. We're gonna do compressor container, and we're gonna pass in the request. Okay. I think everything else is basically correct. We just need to run. So I'm gonna open here. Let's do JSON. Let's take a look at the input. I'm pretty sure it's source, just source bucket source. Yep. So let's do source bucket. Let's do source key. Thank you. That is not correct. I'm pretty sure it's just DST. So we're gonna fix that. And now for the most part, the buckets that we're gonna use are gonna be the same. Let me make sure that this. Okay, this is good. Cool. Let me just examine this. Let's just pick a nice good file to test this on. We're actually gonna let's do something a little short, just so we don't have to spend that much time on it. Yeah, let's just do this. Yep, let's do this file. Okay, So I have a bucket, Swift tests dash v1. I'm gonna use the same test, the same bucket as my destination actually. And then I'm looking to take a peek here at this. And I'm gonna throw in the uncompressed file. And then we're gonna take this uncompressed file and we should expect it to be uncompressed.gz. That's the destination key we want. Do not save this actually. I just want to stringify this. Let's copy that. Let's take it here. Okay, I think this is right. It starts to look a little fuzzy when there's just so much on screen. I'm gonna save this run compressor. I'm just gonna chmod +x to my scripts, my run compressor. Okay, and then let's just test it. Because why not? Let's validate a couple of things before we do compressor tasks. I don't open the task definition, but I do want to take a look at some of the metadata here. Essential container, compressor. Excuse me. We're going to try to run a new task just to see here. So in the cluster, I'm pretty sure we can validate from our CDK code, but I'm pretty sure there is a compressor container. Yep. Okay. Let's delete this. Let's run it. So all we need to do is just run this script. Okay, let's see. So here we're actually passing pre-created. Let's go back to our console to take a look at the status here. It is refreshing. This is provisioning. Let's see. Okay, open the task. Looks like it's running. Let's go to the logs here. Nice. It is baffling how quick containers have become at AWS. 13 seconds ago, this was completed. If we just take a look at when it started, like, it literally took 32 minus 4, which is 28 seconds, to download a container from ECS, from ECR, spin it up, and run my code. Crazy. Alright, now I'm not going to be able to show you the S3 bucket, just because there is a little bit of sensitive information. But I will be able to... That's crazy. The compressed file was actually larger in size than the uncompressed file. So I'm actually going to do a couple of things. I am going to use the CLI to show you guys AWS S3 API head object. I think that's the API. Let's just validate. Let's just do dash dash bucket and dash dash key. So we were looking, I thought we needed something else. Forget about this guy. We should name this compressed just to avoid confusion. Let me run this again while I type in my command. It likely will be done. Script run compressor. Very cool. So let's grab the name of the bucket. And this is why, for an example here, it's just much quicker to just run the test. And I'm already going to need to deploy this anyways, so might as well run the test there. It becomes really hard when it's a project that's an open source project that's managed by hundreds of people. If it's just me that will ever maintain this code, then yeah, I mean, I know exactly how to test it, although I forget sometimes, so it's helpful for me to have the test so I can just go in and run it and know my code works when I make changes 2 years later. But yeah, it is really hard to maintain code that you've even written yourself if you just have no context. Cool, let's get the file after. Cool. Let me validate that this actually worked so I don't embarrass myself. Cool. So I did not use the right profile. Cool. So as you can see, its content length is 41. Now what's confusing is that the uncompressed. So I'm going to show you guys the uncompressed version the uncompressed version is 24 kilobytes, 24 bytes, right? So it's weird how the compression actually increased the size. But let's check. I mean, I have pigsv running here, so I'm gonna do the same request, but I'm gonna do get object instead, and I don't know if that will work. Control A. We'll try. I doubt it will, but yeah. Okay, so we're gonna need to do AWS S3 CP S3 : and then let's do. I actually have it copied in my clipboard, which is nice. Other one. Uncompressed. Cool. Let's do the following. Let's just do it in the same folder we're already in. I did also miss my profile Swift. Cool. So this is what I have in my uncompressed. I don't really know what this actually means. I just typed in binary. And then let's run pigz on the uncompressed version. Okay, now let's do an LL uncompressed. Yeah, it's 41 bytes. It's crazy. Now, ungunzip, gun gunzip, just to validate. Yeah, it's wild. Nothing got corrupted. So now I'm gonna play with a more intense example. In the same bucket, I'm gonna move a relatively large object. So I'm gonna move an object of the size of pretty sure we used one that ended in 70, and we're gonna choose this destination. And for whatever reason, it doesn't look like are you telling me that I cannot copy this? I say, forgot that we did that. So it's good to know. Let's see. I'm gonna do something really quick. Might need. Oh, that's wild. I didn't know you can do that. Okay. Let me try it from the CLI. Is this thing still running? Cool. Let's don't. CPS3 Swift. Okay. We are cooking with gas, as my friend would say. It's great. It's about a 200 gigabyte file. So we'll run tests to see how quick this this compression thing can take. Just for the download right now, and it's probably it's gonna take a couple minutes to just download the file even. It's great. Okay, guys, we are at halfway. We are still waiting for the rest of the file to be uploaded. But yeah, while we wait, we could write unit tests, but we're just gonna keep on chugging along here. Yeah. Alright, about 60 gigabytes remaining, so should be. This is giving us good benchmarks. This is using the AWS CLI, so ideally we can get, maybe that's something we can add while we're waiting to see, is some benchmarking around that. Let me see if I can separate this. Copy. No. Yeah, this will really be a testament to Python, Python streaming ability. I mean, it is an interpreted language, and there's probably tons of garbage collection happening, as well as the cost of interpreting commands. But I think Python's networking module is pretty solid. I run into issues with Node all the time when it comes to networking, when heavy I/O that either works on the file system because it has to tap into libuv, the C++ bindings, all that. It's usually pretty slow, but I love writing JavaScript. It's just so easy for me. But yeah, we'll see. We're almost there. So just to download the file took about 5 minutes so far, right? We started about 19. At 19, I need to double check the time. I'll need to go back. But yeah, we started around 19, and the file just got copied. Okay, let's see. Just gonna try to validate that there is indeed the file is there, which is great. So now let me kill this and let me move back. Okay, so let's see. Okay, let me remove the uncompressed file. And now let's just run this. So let's change the request here. I'm gonna copy the name of the object. Okay. I'm actually going to just suffix it with a csv.gz, the same exact file name. That's another thing that I think we're missing in the module. I'd like to delete the file after we upload it back. The other thing that we could consider doing, it's kind of a hack, but it does reduce our code complexity, is to upload it back with the same exact key, but it doesn't give the flexibility of having the same, a different name for it. So I think that's okay. But yeah, let's see. Scripts run. Whoa. Oh. No, wait. Scripts. What is TMP here doing? Well, everything seems to be working, and that's the beauty of having like a template that you can follow. Just makes it much, much quicker. So that's the same thing with unit tests. I think once cool, let me validate here. So I'm going to be uploading it under the same name .csv.gz, which is cool. So this will start failing, mostly because it's not going to find space to write this. And technically we can attach much more, a lot bigger storage, up to 200 gigabytes, I think. But even 200 for this type of file is cutting it close. What we could do is we could say that we're going to support up to 200, but we need to kind of examine the costs here and see what do a little bit of a cost-benefit analysis. So let's just see. So Fargate, ephemeral storage cost. Let's take a look, and then let's take a look at EFS. Let's just take a look. All right, I'm running in Oregon simply because that's where I am. I live in Seattle, so kind of this makes sense for me to run there. It's closer to me. It's about half or for just in one zone. And given that we are not in multiple zones, so they charge by amount of storage, really. Like there's no charge for bandwidth. Let me just double check. Let's see, what is it charged up to? There is no minimum fee or set of charge. You pay only for what you use. How to calculate the effective storage? Okay, let's see. So in 1 month, based on the average space used throughout the month. Yeah, we need to do the math. So we're only gonna need this file on disk for a very short amount of time. We're talking less than an hour a day, maybe, because or less than a couple of minutes actually. Consumer file says uses 100 GB EFS one zone So this is 100 gigabytes. So we're about 200, 300. What is the throughput? I don't really need replication. So yeah, that's gonna fail. I mean, we can just take a look here, but yeah, it's just gonna fail. Let's go to tasks. I'd be still trying to download. What is this? Started 25 minutes ago. Nope. Probably looking at. For now, it's still running. Yeah, we need better logging because until this exits, don't really have anything. So, anyways, so where are we? Let's look again at pricing. Change over time. Yeah, let's use the pricing calculator. That might be a little bit easier. I'm also interested in just looking at EFS here. I have a feeling that the EFS is going to run into a problem where, let's see. Yeah, it looks like you have one file system here. So if we click on create file system, it asks you where it is going to run all that jazz. Let's just open this one. Interesting, you don't actually specify. EFS, let's just look at the throughput. GB bytes. I'm actually interested to know what this means. I think this is what I interpret as a GB. Yeah. Because unfortunately, I think when we say gigabyte, one is 1,000 and one is 1024. Yeah. We'll go back. Yeah, it's just stupid. It's kind of weird. Um, anyways, GB bytes of throughput over 5,000. Single digit performance. It's on a case by case basis. Interesting. Okay, so we're gonna want to figure this out using this. Let me see the pricing calculator here. Let's go to EFS. Let's click on configure. Yeah, as I said, we're running in US West 2. Change region. It's okay. So, yeah, so like think about it this way. Like let's just say 1 hour a day, right? We're gonna have 200. Let's just say 200 gigabytes. That's baseline off of that. So at the end of the month, it's 24. But it's like at max, you're at 200. Um, most other times, you're using nothing. So zeros. So then let's just say 200 at most. Yeah, that's if now if we add this, this obviously increases our costs a lot. But we can just let it burst for us. Just going back here, right? Where was this? There we go. Let me keep this somewhere just to myself. Actually, not sure here. Let me see. Not this. But yes, I use a private project to track this. Let me see here. EFS performance metrics. Let's read a little bit about this. The final thing, by the way, this should have failed already, but I guess not. So yeah, this gave us $2 if we and I'm just reading off of this, right? The standard performance mode um, yeah, I'm trying to see here. You set the performance mode. Can't change it after for the vast majority of applications. If you're not sure your performance, choose general purpose performance to stays within the IO 100% IO limit. CloudWatch metric can scale elastically up to the limit associated with the performance node. They are not billed separately for IOPS. They are included in file system's throughput. Every network file system request is accounted for as 4 KB of throughput or its actual request and response size, whichever is larger. That can drive 100 Mbps of throughput, can drive up to 25.6K 4 KB writes per second. Gotcha. megabytes of both read and write. Let's see the default throughput quotas. So these are okay. So 3 GB per second. I think that's very reasonable. Like our system can definitely handle this. Let's compare this with the price of storage. Let's take a look. Who's available? You only pay for any additional you configure, which we did not. Still loading. Seems like they have. There's something broken in there. One of my favorite things is inspecting websites that I don't own. Just gonna open the network tab really quick. Munchkin in it. Interesting. There is something running here. Failed to load. Let's take a look at what's happening on the network. It's an interesting file. Okay, I'm gonna open this on Firefox because I don't know, I feel like I'm struggling to open this. Let me just do a new window here. Let's kill this. There we go. Things are loading here. Nice. Okay. Per hour, and then you're limited to 200, I think. That's the problem. Storage only available for ECS. Let's read a little bit about this. Fargate, ECS, larger ephemeral storage. This was announced last year. Okay. Charged per hour. Let's open the AWS pricing calculator, which I've. It's honestly pretty cool. Yeah, let's take a look at this. Yeah, so it's charged by the second, so this is just per hour. Nice. It's charged per second. Is very good. So technically, we could say that we are this much. Now let's just say it's an hour every day. So 24 hours. That is very, very cheap. Oh, that's per gigabyte. So 180 times that. So it's much, much cheaper, but you don't get the benefit that it's like elastic. So that's something that we can think about. One is $2, the other one is about 50 cents, but I'm pretty sure the other one we kind of miscalculated it because I think it's the average. It's one of those things where you need to kind of do to be able to understand what the cost would be. But yeah, this is great. I am going to let's take a look at our AWS run. I can't believe Chrome failed me. There we go. CSV, no space left on device. See? So this makes sense. Like, I totally get this. I think EFS can be a quick follow-up. Basically, we can just add some code to do some if checks based on the size. But yeah, ideally we just use EFS. Alright, maybe I'm gonna call it here. I'll set up another stream to actually go over EFS. Here we just did the download and everything under 20 GB. So now we just need to scale it, figure out how we scale it. Alright, with that, that's not really a great ending, but that's okay.